on the cloud. Okay. In your Western Online, I added a in the course content, I added materials for the final weeks where I am going to discuss confidence interval, test of hypothesis, correlation, regression, and optimizations. Clear, right? And then by this Sunday, 11:59 p.m., you will have your exam on probability distributions. Clear, right? Okay, that exam will be very easy exam if you know the Python code and understand what distribution should be used. Then entire examination would be maybe 20 to 25 minutes, 30 minutes, not more than. Okay, first problem. Yes.
Before we start, Claire and I were looking over like the Western Online, and we saw that the first time midterm exam, a quiz popped up.
Yeah.
It was due on the 17th, but none of us had October 17th, but it just popped up for us.
This assessment?
It's in the quizzes.
This one?
No, the first time midterm exam. That one. Yeah, that just popped up.
You already took this one, right?
So that one. But that one just showed up for us.
Let me see what is in there. There is nothing. There is nothing, okay?
Okay.
That one I should delete. Happy?
Sorry, we were just a little confused about it.
Okay, let me start, okay? First topic, I'm going to discuss about confidence interval. First topics that I'm going to discuss about confidence interval. Okay, we always use the word confidence interval in our lifetime. We said I am 70% confident that we are gonna win football match between Western Illinois versus Quincy University. Understand? Western Illinois or Eastern Illinois. We always say that, right? There is a 70% chance of rain. Okay. There is a 60% chance of snow, right? Understand? So those are the things we already make prediction or make those comments we already make in our life. How those comments are made, that is known as the confidence interval, but the computations is done by using statistical distributions and the data coming from the sample. Okay. So let me explain these things. Suppose, take a look at this example. Suppose WIU students spend on an average $10 for the lunch. $10 mu equal to mean equal to they spend $10 for lunch. Understand? Mu equal to mean equal to $10 for lunch. WIU student spend for. So someone said that $10. Then I said that, well, let us check whether this claim is true or not. Okay. So what I did, I sent her to 100 student. She went to the 100 student. Okay. From the 100 student, she got 100 observations, right? How much money did you spend? $9. How much money did you spend? $8. How much money you spend? $14. How much you? $6. She went to the 100 students and she collected 100 observations. From that observations, she computed the mean X bar, and then this is a Z value.
that is coming from the table, and this is a standard deviation, this is a square root of n. She plugged this value x bar plus z s over square root of n. So one time she computed these values and another time she computed that. This is a comma, okay? This is a comma. This is the comma we use. So she computed this value by plugging value x equal to, suppose her mean is suppose equal to $12, and this is equal to 1.96, this is equal to 5, and this is equal to 100. And then another one, again $12 is her mean, 1.96, and then 5 over square root of 100, over square root of 100. So this is the way she found the mean. Okay, this is the way she found the mean. Okay, this is the way she found the mean, and these things has been computed. Okay, so now suppose this thing is coming 9.69 and these things is coming 11.29. So this is what we got the value. Okay, so this is 9.69 and that is 11.29. Are you understanding? This is her confidence interval. Suppose her name is A. Okay, and then I again asked this girl, she went to the another 80 students, she collected the data and she computed the mean and standard deviation of that data. This is a fixed value coming from the table which I'm going to discuss, and n equal to 80 she plugged and she got this. Okay, this is the B. This is her confidence interval. Okay, and then this boy went, he collected the data, he construct the confidence interval, he got confidence interval like this. Okay, okay, this boy collected data from the people who spend lot of money. Understand? Who spend lot of money. So that is why it did not cover that one. That is the true mean. Okay, and then she went, she collected the data. This is C. She went, she collected the data. This is like that. This is covered. And that boy in the back, he went, he collected the data. He went to the people who are very health conscious and who spend less money for the food. And then his one did not cover. Are you understanding? So this is the mean and this is the minimum and maximum coming from this and that formula. Subtracting and addition with the mean, this quantity, we got two number in that way. Clear, right? Are you understanding? Are you understanding? Question or not? You are understanding, right? Good. In this way, suppose we repeated it 100 times. So A, B, C, D, E. So this is way 1, 2, 3, 4, 5. Suppose I constructed it 100 times. 100 people are sent to collect data. 100 people collected samples of different sizes, and then we constructed this. I found that out of 100, 96 of them cover this 10 value, 96 of them. Remaining 4 did not cover. Again, I sent another 100%, and then those 100% constructed this, and then among those 94 of them cover. You understand? Another 100 I sent again, and then I found that 95% of them cover. So this is on an average long run, 95% of them, of those confidence interval cover the true mean. Why I said 95%? Because in this case, Z value that I am using, this Z value is called the 95% Z value. So that is why we call it is 95% confidence interval. Now, how Z value is constructed, that must be specified in the question. Are you seeing in the question confidence interval for mean by using Z value? This is the formula when population standard deviation is given, 95% confidence interval. Say 95% is given. This is the formula when population standard deviation is not given and sample standard deviation as needed to compute it. Now, this is the real life problem. This is the problem I'm going to solve. A sample of n equal to 60 night school students ages is obtained in order to construct confidence interval for the mean age of night school student. Okay. The result is the average age of the night school students is 25.3. 25.3. Okay, with a standard deviation of 4. With a standard deviation of 4, that means S equal to 4. With a standard deviation of 4. Okay, these are the things given. Construct a 95% and 93% confidence interval for me. Clear, right? So now, first of all, I have to construct a 95% confidence interval. Let me explain these things to you clearly. 95% confidence interval means middle 95%. I want to have here 95%. Here 95. Are you understanding? If you do not understand this basic concept, then you will have a trouble. Clear, right? Clear, right? Their question is saying construct 95% confidence interval. So I need this value, that value. Okay. Everyone ready? If this is 95%, how much is this one? How much the red person? How much the red area? Now red part is what part?
Oh, 50.
This is 95 shaded area. Red part is what? It is symmetric. 47.5, right? This is 47.5, right? And that is also 0.475. Do you understand this or not? It is called 95%, right? 95%. So this is a 95% as I mentioned in here. This shaded area is 95%, okay? Then half of this equal to? Half of this equal to? That. Thank you. So if this is 475, how much is in there? How much is this part? Uh-oh. How much is this part? How much is that part? This yellow part, how much?
Zero to 5.
Fantastic. Good, right? Normal distribution and T distribution, it is always symmetric. 50% in the left side of the zero, 50% is in the right side of the zero. I understand? Okay. Now I have to find this value. Take a look. Now I have to find that value here. This green. What is the Z value in here? Okay. Let me write it by green. Z 0.025 equal to 1.96. Okay. Because this is negative, right? 1.96. Are you understanding? Same Z 0.025 equal to positive 1.96. Why? Because this is that part. That is the positive part. Are you understanding? Take a look at the board, please. I know Z. Everyone, please take a look at the board. I write here Z. This is the same thing. One is negative, one is positive. Why? Because before zero, everything negative. After zero, this is positive. This is also 0.025, right? That is also 0.025. So 0.025, so this value is 1.96. 0.025, this value is negative 1.96. Are you understanding? So in terms of notation, when we write this notation in this format. When we write in terms of notation, we write this 0.975. Do you understand now? Who is confused? Anyone get confused in here? Looks like you are confused. Okay, let me again explain this thing. I write here 0.025, right?
Okay.
Take a look at the board in order to understand. I write here 0.025. 0.025 is this yellow area, okay? So that is why negative 1.96, negative 1.96. And I write here 0.975. 0.975 means this area. This entire area. Let me draw this 0.975 equal to this entire area.
Okay, I get it.
Okay, so that is why it is equal to positive 1.96. Clear, right? Are you seeing then one negative, one positive sign? Are you seeing a negative sign, a positive sign? This negative sign is coming from here. This negative sign is coming from here. And this positive sign is coming from there. Clear now? Everyone ready to now solve the problem? So you understand basic thing, right? Okay, let me solve the problem quickly. So now I have given n equal to this, x equal to this, s equal to this. Find the 95% confidence interval and then we will find 93% one. So 95% one. So let me open a new one. Okay, let me find here 95% confidence interval is formula equal to x bar minus z 0.025 s over square root of n, comma x bar plus z 0.975 s over square root of n. Okay, now let me plug the value. If I plug the value, then it should be 25.3 minus 1.96 and s equal to 4 and then square root of 60 comma 25.3 minus 1.96, it should be plus 4 over square root of 60. Okay, then someone of you please help me to find this value. 25.3 minus 1.96 times 4 divided by square root of 60. This entire document that I have uploaded in the Western Online has all the final exam questions, okay?
So I got 24.287.
287. And then other one?
Other one was 26.312.
312. 24.287, 26.316. These are the results she got. I believe her, okay? Understand? Clear, right? Now give
half a minute attention to my words, what I'm saying. Okay? After finding confidence interval, how to explain those things? I am 95% confident that the average age of the night school students age lies between 24.287 and 26.316. That's the way you have to write your explanation, understand? When you will do job and they will ask you, find the confidence interval of the ages of the people who are using our credit card. Understand? This is your business major, right? You are doing business major, right? If you work in a JP Morgan or Wells Fargo, they will ask you, find the confidence interval of the age of the customer who are using our credit card. So this is the way you have to find the confidence interval and have to report to the audiences. Understand? I am 95% confident that average age of the night school students lies between 24.287 and 26.316. Clear, right? Okay. Now you can ask me, how did I get 1.96, right? 1.96, this is the things you have. You can ask me question, Dr. Chaudhary, how can you get that 1.96? Could you please help us to find that? I said yes. Tell me what code you write last time for finding Z values for the standard normal distribution. You remember we wrote here state norm CDF 2, right? Norm CDF. Now we can write here PPF, right? PPF, and then we have to write here. We have to write here 0.025, right? 0.025, 0.1. Oh. Now control enter states. I need to import those things. Are you seeing negative 1.955? I put a negative 1.96, right? So no confusion how to find Z 0.025, Z 0.975. You understand, right? I write here Z, right? I write here Z. I write here that. I write here this Z 0.250, Z 0.975. If you want to take a look at the other one we can also find. Just change it here, the value. Nine. See, 1.9, not 925. It's not 925. It's 975. It's 975. 975. $1.96. Are you seeing? Understand, right? Okay. Now, as you understand how to do these things, could you quickly help me to find the 93% confidence interval? Rest of the value will be same. This value will be as it is. This value will be as it is. This value will be as it is. This value, this value, this value, that value will be as it is. Only difference will be in here, 93%. Could you find the confidence interval for me? I want to give you next 5 minutes. See,
the formula will be this, X bar minus Z 93%, right? So 93% means 7%. 7% half equal to 0.035 S over square root of N, comma, X bar plus Z 96.965 S over square root of N. 93 and 0.35, yeah. So find this value. Compute this value for me, and I want to see who can do it quickly. So this value, that value are the same. This is equal to, that is equal to your X bar equal to 25.3. Let me write it in here. X bar equal to 25.3, S equal to 4, and N equal to 60. These value as it is. Only these things you will have to find. I want you to do these things quickly for me and make me happy. I randomly check one of you. If you cannot do this, I'm gonna insult you. And I'm randomly going to check. What is one of these value? Can anyone of you tell me? Z 0.035 equal to what? 25 point? No. Hope. Did it? What is this value? Negative 1.8. This could be true. This is true, right? I know her name. I do not know any other name because she made couple of Zoom meeting with me. So that's the reason. Okay, who can help me? Z965.
Positive 1.
81. By symmetry, right? By symmetry, right? Anyone is struggling to understand these things? Anyone want me to clarify these things again? Everyone is okay? Are you okay, gentlemen? Sure? So then let me go to the next problem then. So what we learn in here, how to construct confidence interval when the sample size. So this is the formula. This is the formula is given. In this format, I explain these things in here. So in your exam, when you see the problem, so match these, what are the conditions and whether these assumptions and condition are matched, then you use this formula to compute this, okay? Okay, now come to the next problem. Confidence interval for mean by using t value. Are you seeing I write here t value? Previously, I wrote Z value. Previously, I wrote Z value. What is the difference between T and Z? Let me explain. Z distributions looks like this. And here is the mean, which is equal to 0. T distributions looks like this. It has a mean in here, 0. Okay. So the difference between Z and T has a smaller variance. Clear? And this distribution is appropriate when n less equal to 30. When less than 30, you will use T. This is called the T and this is called the Z. The left one is called the Z when n greater equal to 30, and when n less than 30, then it is called the T. Clear, right? In your exam, when you will read the question, pay attention on the size of the sample, whether n is greater than 30 or n is less than 30. If greater than 30, use the Z. If less than 30, use the T. Clear, right? Okay, now let me read the question. Consider the following data on the number of pounds lost by 8 customers in a weight loss clinic at Washington, D.C. over a period of 2 months. Assume that the weight loss is normally distributed and data are these. Okay, data are these. Construct a 90% confidence interval for mean, 90% confidence interval for mean. So the formula is going, we have to find. Okay, let me enter the data in the Python. D1 equal to 19, 27, 24, 19, 27, 24, 20, 17, 25, 20, 17, 25, 28, 16, 28, 16. This is the data we had. Now find the, let me see, D1 dot mean. D1 dot mean is not giving us, let me see, D1 dot average. Oh. Did you need to look the data frame or hold on? Let me put here another bracket. Let me see now whether this will work. D1 dot mean. Uh-oh. Mean average none is found. Why did I forget such a silly thing? Download. Okay, as I'm struggling, I have to take help from the code that I have provided. This is very annoying for me. Week 1 and 2, basic computations part 1, basic computations part 1, Python file. download. I have downloaded. Let me open it. File. Open. Download basic computations part 1. Ah, that is the reason. Okay. PD, I have to import the PD. Okay, so first of all, let me bring the data again. Here. Let me bring the data again. And then I just want to put here df dot, I have to import pandas, panda spd, pandas or panda? Pandas and pd, then I have to write here df equal to pd dot data frame, and then I want to just write d1 and then df dot mean. Hopefully it will work. Is it working? 22 mean I have found. Okay, I have found mean equal to 22. Clear, right? You notice how I struggle, right? Actually, that was a fake struggle. Why? I want you to know that nowadays, because lot of things in your head, there is a huge chance you will forget. So we have 22. So let me see whether we can get the standard deviation. SD. Okay, SD is not found. So it is written as STD maybe. STD. Clear, right? Understand, right? So for doing this, I need to use this formula x bar plus minus t 0.95 s over square root of n. Okay, s over square root of n, and then 0.95 after 0.95 n minus 1 is given, right? So now what I will do, we have x bar equal to this and s equal to that, x bar equal to 22, s equal to 4 point, x equal to 22, and s equal to 4.59. Okay, now how can I find this one? This is the 95% confidence interval using the t looks like that, 95%, that is 0.025, and that is 0.025. So what you will have to write, you have to write a code Control V, and then I have to change here, instead of norm I want to put here t, and then 971 degrees of freedom I have to put here, and -1, that is 6 minus 1, 1, 2, 3, 4, 5, 6, 7, 8. That is the 8 students, right? 1, 2, 3, 4, 5, 6, 7, 8. Are you seeing there n-1? Are you seeing n-1? Okay, that is known as the degrees of freedom. So I want to put here 7. I want to put here 7, and let me see how the results. Results is 2.36. Understand? Result is 2.36, or results would be negative 2.025, or negative. Are you seeing symmetric value, right? Symmetric, right? Clear, right? Clear, right?
So two confidence interval we have learned. One uses Z when N, sample size N greater than 30. Another uses T when sample size less than 30. Clear, right? So in your exam, when you read the question, please pay full attention. Okay? Don't make a silly mistake. So that means if I plug this value in here, that should be negative 2.36. This is positive 2.36. Okay? So these are we learn confidence interval for the mean when sample size N greater than 30. Confidence interval for the mean when samples are less than 30. One I use Z distribution, another one I use T distributions. Now third problem we are going to learn confidence interval for the proportion. Okay, and after that we will start test of hypothesis. Confidence interval for proportion based on health and nutrition survey, it was reported that 35% of US populations, 35% of the US population 18 to 74 years of age take vitamin supplement regularly. An investigator interviewed 300 randomly picked individuals in the age group and found that 125 of them took the supplements. Okay, construct a 88% confidence interval for the population proportion. Okay, so now here population proportions they want to construct. So the formula is this: P hat plus minus Z 0.95, P hat 1 minus P hat over N, and then this is what we have. This is the formula, okay? Now P hat equal to what? P hat equal to an investigator interviewed 300 randomly picked individual in the age group and found that 125 of them took vitamin supplement, so which is equal to 5 equal to 12, right? So 5 over 12 equal to 0.48. 0.41. 0.42, suppose. You are understanding, right? So now I want to plug their value 0.42. This is the value that I know, 1.96. And then here I want to put 0.42, 1 minus 0.42 divided by 125. Okay. Clear, right? And then after what you will get by doing these things, you will say that you will say that 95% confident that proportion of people in the age group 18 to 74 take vitamin supplement between this and that. Clear, right? Okay. So yes.
So 125 is the sample, is N instead of 300?
Oh, this should be 300. Thank you. This should be 300. Thank you. Good question.
Now we want to do test of hypothesis, okay? In order to do the test of hypothesis, okay? I have to explain two approaches. One is p-value approach, two approaches. Two approaches to reject or fail to reject two approaches to reject or fail to reject null hypothesis. Okay, two approaches. Two approaches. Two approaches to reject or fail to reject null hypothesis. Two approaches to reject or fail to reject null hypothesis. One is p-value approach. Okay. So reject null hypothesis if p-value is less than 0.05. Okay. Fail to reject null hypothesis if p-value is greater than 0.05. Understand, right? This approach you are gonna use when you use Python. This approach you are going to use when you use Python. Clear, right? Which I'm going to show you in next class. This exam will be also easy, test of hypothesis, confidence interval. Why? If data is given, you just put it in the Python, result will be given. Understand, right? Second approach is, what is second approach? If calculated value is greater than table value, reject null hypothesis known as H0. H0 is the notation of null hypothesis. Number two, if calculated value is less than table value, fail to reject H0. Clear, right? Two approaches, right? The second approach I'm going to discuss in the class. The first approach, p-value approach. Next class, when I run the Python code, you will see. Clear, right? Right? Okay. Now, what is p-value? What is p-value? That is what now I'm going to discuss. So, in order to know the p-value, I have written a very beautiful comment in this is the final week's material. Let me see whether it is in there. Okay. copy these things. Let me paste it in here if possible. Control V. Okay. See, what is p-value? In statistics, p-value is the probability of obtaining result at least as extreme as the observed result of a statistical hypothesis test, assuming that null hypothesis is correct. They said as extreme as in statistics, p-value is the probability of obtaining results at least as extreme as the observed result of an statistical hypothesis test. Now take a look at that. In statistics, p-value is the probability of obtaining results as least as extreme as the observed result of a statistical hypothesis test, assuming that null hypothesis is correct. She is collecting data. She is collecting data. Okay. If she collects the data, she finds that one student spent $33 for the lunch. It is very extreme, right? Okay. And the probability of that extreme observations is also low, right? You understand? So in such a cases, if her average is also very high, because some of the observations coming is very high, so that means the average is very high, that is observed. Your average is found like $12 and her average of expenses for lunch found $22. So her average is, we observed by our eyes that her average is higher than your average, right? And then that is why the also true for the probability. In statistics, the p-value is the probability of obtaining result at least as extreme as the observed result of a statistical hypothesis test, assuming that the null hypothesis is correct. The p-value serves as an alternative to rejection point to provide the smallest level of significance at which the null hypothesis would be rejected. When I will start computing these things, I will discuss how to compute these things, how to compute p-value by using paper and pencil approach. A smaller p-value means there is a stronger evidence in favor of alternative hypothesis. So that this is what I wrote in there. I wrote in there, reject the null hypothesis p-value less than 0.05. So it was also mentioned. Now, let me explain first what is null hypothesis. Null hypothesis definition is, what is null hypothesis? Null hypothesis, okay? Hypothesis that we want to test for possible rejection. Hypothesis that we want to test for possible rejection under the assumption that it is true. It's called null hypothesis. Okay. So what is the definition of the null hypothesis? The hypothesis that we want to test for possible rejection. Okay. So last year average expenses was $10. I want to check whether the average expenses is still $10. Do you understand? The hypothesis that we want to test for possible rejection under the assumption that it is true is called null hypothesis.
So null hypothesis is usually the hypothesis of no difference. For example, null hypothesis is denoted by H0. Okay, H0. And it is written as mu equal to 10. Okay, mu equal to 10. Average expenses for the lunch by the WIU students is $10. Okay. Any hypothesis other than null hypothesis is called the alternative hypothesis. So there are three ways alternative hypothesis could be written. Three ways alternative hypothesis could be written. How? Number one, H1 is the notation of the alternative hypothesis. Alternative hypothesis that student spend more than $10. Okay. Number two, then student spend less than $10. Okay. Number three, student spend the amount that we do not know. Are you understanding? This is the non-hypothesis and that is the alternative hypothesis. Okay, this is the alternative hypothesis, this is the null hypothesis. The hypothesis that we want to test for possible rejection is called the null hypothesis. Any hypothesis other than null hypothesis is called the alternative hypothesis. Clear, right? So now the next question is, among these three, which alternative hypothesis I should pick? Okay. By reading the question, you have to decide. Alternative hypothesis is also known as the researcher hypothesis. That should be given in the question or that should be decided by the researcher. So for example, in your exam, by reading the question, you have to identify whether it will be greater than or less than or is not equal to. If it is greater than, it is also called the right-sided or right tail. R-I-G, right-sided or right tail or right tail. Okay. If it is less than, it is called the left-sided or left tail. If it is not equal to, then it is said both-sided. Both-sided. Clear? Okay. At the beginning of the class today, I started discussion about confidence interval. 3 confidence interval problem I discuss, and you understand those things. I give all the rationale. Then I have started. You have a question?
I was just asking, on the test, if it's like mean is less than 10, do you want us just to say that, or do you want to say it's right-sided or right?
So in the exam, first of all, you have to do, okay, when I will solve this problem, I will discuss this, okay? So let me first explain this thing. So null hypothesis, by reading the question, you have to set up one of these 3. So number 1, by reading the question, you have to set up H0 mu equal to suppose 20 and H1 mu is greater than 20. Either this one, number 2, H0 mu equal to 20 and H1 mu is less than 20. Or you have to set up number 3, H0 mu equal to 20 and H1 mu is not equal to 20. Take a look at the board, please. By reading the question, you have to choose one of the 3. Understand? Null hypothesis is the hypothesis of no difference. Alternative hypothesis is the researcher hypothesis. Either it will be specified in the question, or if you conduct your own research, you have to set it up. Clear, right? Now let us solve the problem. A test of hypothesis has 4 steps. Okay. Step 1, setting up
A test of hypothesis has 4 steps. Let me write it in here. So it has 4 steps. Step one, setting up null and alternative hypothesis by reading the question. Step 2, calculate test statistics value. Number 3, find table value. You remember the Z table, there is also T table, there is also F table. And number 4, step 4, decision of rejecting or fail to reject. Okay, these are the things. Are you understanding? So now we are going to do first test of hypothesis problem, and I'm going to write these 4 steps. Okay, just take a 5 minutes break. Just take a 5 minutes break, then I will start doing this. (34). Take 5 minutes break. I will start at 4:40. So I give the basic idea. Now rest of the thing I will go quickly. Okay, so it is now 40. I gave you. Let me quickly now solve this one. Okay, take a look. A sample of 60 ninth school students' ages is obtained in order to estimate. In order to estimate the mean age of 90 school students. See, I'm reading the question and setting up all 4 steps. The results is x equal to 25.3 years with a standard deviation of 4. At a 5% level of significance, can you conclude that true mean of 90 school students is more than 25? It is said more than, right? Are you taking, please look at the board. It is taken more than 25, right? So then alternative hypothesis, mu equal to what? Right? And null hypothesis, u equal to 25. So this is the step 1. Okay. How many steps? 4 steps, right? Number 1 step's gone. Number 2, calculated value. Z cal value equal to what? X bar minus mu 0 over S over square root of n. Okay. So what is my mu 0? The mu 0 is this 25 is my mu 0. Okay. Null hypothesis equal to mu 0. So x bar equal to 25.3 given in the question, mu 0 equal to 25 and S equal to 4 and then n equal to 60. Are you seeing the value? Are you seeing that? So if you plug this value, then what we are going to get in here? 0.3. Can any one of you tell me the value of this? 25.3 minus 20 divided by 4 times square root of 60. What is the value? Tell me.
That 0.581.
0.581.
81.
This one. So now number 3 is what? Table value, right? So Z table. This is the table value. Clear, right? Third steps is the table value. Didn't I write these 4 steps in there? These 4 steps for conducting test of hypothesis. These 4 steps you have to follow all time if you apply paper and pencil approach. But if you apply the Python approach, you just take a look at the p-value and give a decision. Clear, right? Okay. Come in here. Now, Z table value. Are you seeing 5% level of significance? Are you seeing this 5% level of significance? This 5%. Okay. Are you seeing that, right? So now I want to draw the figure. I want to put all 5% in there. Do you understand why I put 5% in the right side? Why I put 5%? Are you seeing this 5%? At 5% level of significance, can you conclude that true mean age of 90 school students is more than 25? Why I put this 5% in here? Who can answer my question?
If you want more than 45?
You're close. My question is, there is at a 5% level, why I put 5% in the right side? She said more than. Is almost correct. Take a look at that. If your alternative hypothesis is greater than, then this 5% will be in here. Understand? If alternative hypothesis is less than, then this 5% will be in there. Okay?
If this alternative hypothesis is not equal to, then 5% will be split in half and distributed equally in the two parts. Understand? Understand? You understand, right? So now, if this is equal to 5%, how much is in there? $95, right? Right? So now how can I find that value? I can find that value. That value we can find. States, norms, states norm dot ppf 0.95 0,1 will give us 1.64. Are you seeing? Your life is so easy now. When we are a student, we are given this table. I show you normal table last time, T table. This is the T table. This is the T table, okay? But you are using Python, right? Then we during the exam time, this table was provided, and then Z table, F table. F table. Com F. Okay. So now, number 4 is the decision. Number 4 is the decision. Decision. Okay. Since Zcal is less than Ztab, we fail to reject null hypothesis H0. Clear? We fail to reject null hypothesis H0. Okay. Now come to the next problem. One sample test using t-test statistics. Now, in this case, consider the following data on the number of pounds lost by 8 customers in a weight loss clinic at Washington, D.C. over a period of 2 months. Assume that the weight loss is normally distributed with data this. At 1% level of significance, we conclude that true mean weight loss is more than 20 pounds. So step 1, we want to do null hypothesis, mu equal to 20, and alternative hypothesis, mu getter equal to 20. Number 2 is the T calculated value, which is put x bar minus mu 0, this is mu 0, this is mu 0,
over S over square root of n. X bar equal to what? X bar equal to the mean of that, right? Which is equal to 22. We already computed that things before. And S equal to what? Four point
5.9.
59 divided by square root of n. Alter tab. Hmm. 4.59. Thank you. So could you tell me what is this value then? Twenty-two minus 20 over 4.59 and n equal to 8.
Is it 8 or 7?
8.
About 1.232.
1.232, right? Okay. Now, how can I compute this? Again, states. Okay. And then it is called T and then PPF. Okay. And they said 1% level of significance, right? Now you focus how to put 1%. So they said 1% level of significance. Let me write it in there. 1% level of significance. Right? And then take a look at that. Take a look at that. This is a right-sided, right? So that all 1% will go in there, right? Because this is greater than, so this is equal to 0.01, right? If this is equal to 0.01, then this is equal to what? This is equal to what? This is equal to 0.99, right? So then I can write here 0.99 and my degrees of freedom equal to n minus 1. df equal to n minus 1. So if I write state 99 and 7, then we get our result. Come on. If we write here state, I have to write a 7, which is degrees of freedom, and here 0.99, then I get a value, not norm, it should be T. It should be T. 2.99. We got 2.99. We got 2.99. 2.99. What will be the decisions? Can any one of you tell me? Calculated value less than table value. For decision. Since T cal is less than T tab, we fail to reject H0. Clear, right? But you will see very funny when we will enter the data and run the Python code, that they will give you p-value, and in such a cases you will apply the p-value things. Okay. So one piece of advice I want to give you, during the class time, if you pay all of your attention, then 50% of your work is done. So if you say, some people do that, they come to the class, but they do not put attention, and then they go home, they read all the materials. That is the double uses of time. Okay, time is limited at the end of the week, 168 hours. 168 hours. It is true for the president of USA and also a farmer of a world. Okay, those people who get success, they properly use the time. And the class time, you can ask creative questions. So even in the class time, if you come, if you do not like, that is, you are using same thing learning, you are using double effort, you are giving double time, understand? So just a piece of advice. Okay, so now this is the done. Let us do the Z statistics one. Based on a health nutrition survey, it was reported that 35% of US populations take vitamin supplement regularly. An investigator interviewed 300 randomly picked individuals in the age group and found that 125 of them took the supplements. At 1% level of significance, do we have sufficient evidence that more than 35% people take vitamin supplements? Are you saying more than, right? Either more than or less than, or whether we do not know. These are the three things must be specified in the question so that you will determine your alternative hypothesis. So the step one is setting up null and alternative hypothesis, which is mu0 and which is P equal to proportion equal to 0.35 and alternative hypothesis P greater than 0.35. Okay, why greater than? More than. Okay, number two is calculating value zcal. So now this is my P0, P hat equal to what? 125 out of 300, which is equal to 0.42, right? 0.42. 125 over 300 equal to 0.42. So now let us plug the value in here. 0.20 minus 0.35. 0.35, 1 minus 0.35 divided by 300. Can anyone of you tell me what is this value? Then I will go for the third and fourth steps.
Got 2.54.
2.54.
Yes.
So that is the calculated value. God bless you. So let me do the tabulated value, okay? Z table value. What percent? They said 1% level of significance, right? In the question, 1% level of significance is mentioned, right? So that means that has been given as a 1%. That has been given as a 1%. 1% level of significance. Clear? So in order to find that, what should I do? I should write here states, norm, PPF, 0.99 and 0.1. Okay? Which is equal to, I guess, 2.5, 1%, right? 2.58 or 2.32 maybe. Let me see, 3.32. Let me see. 2 point 0,1. Just change it to norm. Two point 32. So that means 2.32. What is your decision? Tell me, I'm not gonna write. What is the decision? Take a look. This is also called the level of significance. This is also called the rejection region. Rejection region. And that is called, let me put here green. It is called AR. That means acceptance region. Acceptance region. This is called the rejection region, this thing, red. Okay? Question?
Solution.
What is the solution?
Would you,
Reject or fail to reject?
you would reject?
Yeah, because calculated value is greater than
Uh,
table value. Good. So, since we write here, since zcal is greater than ztab, we reject H0. That means null hypothesis. Are you understanding? Grace, are you understanding? Okay. Let me solve. Now, the problems that we solved are about mean and proportion. Now we want to do the test of hypothesis for the variance. Okay. So test of hypothesis for variance, 20 observations of the gear diameter are given below. Okay. Conduct a test of hypothesis whether the variance of the gear diameter is 0.01 or not at 5% level of significance. See, here null hypothesis equal to sigma square 0 equal to 0.01 and alternative hypothesis sigma square 0 is not equal to 0.01. Clear, right? Are you saying of the gear diameter 0.01 or not? It is not written greater than or less than, right? Greater than or less than is not written, so alternative hypothesis is not greater than or less than. Instead, alternative hypothesis is not equal to. Alternative hypothesis is not equal to. Not specified, right? So that is why I put here in this format. Okay. Now I have to compute these things. In order to compute these things, let me take the data, find these S square values. So let me copy this data, copy these things, and then go and paste there. Control V, paste there, and then I just put here like this, and then I want to put here like this, D1 equal to like that, and then I want to run the data. Control Z, enter, data has been run. Now I have to do these things, df equal to pd dot data frame, then I put here d1. Now I want to put df dot STD. I found my STD equal to 0.0047. Understand? 0.0047 I have found. So let me plug the value in there. Step 1 is done. And then step 2 is chi-square I want to calculate, and -1, which is equal to the 20 observations of gear diameter. 1, 2, 3, 4, 5, 6, 7, 8, 20 observations. So that means 20 minus 1 S square sigma square equal to 0.01, and as b equal to this, so then variance equal to what? Let me find the variance one. Var var equal to 0.00, that is equal to 0.000022, I guess. 22, I guess. Could you tell me what is this number, please?
I got 0.0418.
0.0418. 20 minus 1 times 0.000022 divided by 0.01, right? Okay. Now I want to find the calculated value. Now, before that, I have to give you an explanation. Number 3 steps and number 4 steps. In order to give the number 3 steps, I have to give you an explanation. This is the chi-square distributions, okay? Chi-square distribution is not symmetric. Normal and T is symmetric. Normal and T is symmetric. Chi-square is not symmetric. Normal and T started negative to positive. At the middle, it is 0. 50% to the left of 0, 50% to the right of 0. But it started 0, ends in here. So that means it is said we are given 5% level of significance. So alpha equal to 0.5. Then half of it will go there, which is written as 0.025, and half of them will come in here, which is known as 0.025. Clear, right? Okay. Now I have to find this value, chi-square 0.025, and degrees of freedom there is 20 minus 1, which is equal to 90. I have to find this value, which is equal to chi-square 0.975, and then this is equal to 19. These are the two values I have to find. Okay? These are the two values. So if calculated value false, that value, this 0.0414 false is in here or here, it will be rejected. And this is called the acceptance regions. AR, acceptance region. That is called the rejection region, this part and that part. Clear, right? Because there is a 1% level of significance, so we have to find that one. So now let us find the table value. Table value. Okay. Table value, we want to find chi-square 0.02519, which we can obtain chi-square 0.97519, which we can obtain by using states dot, I think, chi ppf 0.025, and then degrees of freedom equal to 19. Then that is states chi PPF 0.975 19. Okay, let's check whether my code is fine. I just write it based on assumption. Let's check whether my code is okay or not. Let's check. I hope it should be chi, chi s square, and then it should be 0 to 5, and then it should be 19 and hit enter. Let me see whether this is okay. CHI work. So this is 2.98. Okay, this is 2.98. That is called 2.98. Let's check whether I am writing it in other way. 2.98. It might switch. This one could go that way, and this one could come this way. But we have to check. So let us check. Chi. It should not go that way. The way it is written. 975. Okay, yeah, this should not. So that means that one equal to 5.71. 5.71. Clear, right? So that one equal to 2.98, and that one equal to 5.71. This is my calculated value. These are my tabulated value. Could you tell by comparing these two values, these values, whether we reject or fail to reject?
Oh, I thought that was a general.
No,
I don't.
you don't know? So that one is my calculated value, 0.0418. And these two are my tabulated value. This is my acceptance region. This is my acceptance region. So this value equal to 2.98. This value equal to, okay? That value equal to 5.71. So the ranges is in here 2.98 to 5.71. And 5.7 bigger than 5.71 is the rejection region. Less than 2.98 is also the rejection region. This is the acceptance region. This is my calculated value, and this is my tabulated value. Reject. Why reject? Because calculated value falls in the rejection region, right? Calculated value 0.0418 falls in the rejection region. That is the rejection region, RR. That is the rejection region. That is the rejection region, RR. And this 0.0418 falls in here, smaller than this. So that is why. You are okay? Confusion? 2%, 3%, 7% confusion? No confusion? How about you? You're good? This gentleman, this boy. Little bit confusion? Not an iota of confusion? How about this quiet girl? Are you okay? You're understanding? So what is the purpose? Level of significance is given. On that level of significance, you focus on whether it is greater than, less than, or is not equal to, and then split your rejection and acceptance region and check whether calculated value falls in the rejection region or acceptance region. Focus on level of significance. Construct acceptance and rejection region and check whether your values falls in the rejection region or acceptance region. Clear, right? Okay. Now we want to do two sample test. Okay. Two sample test we want to do. I want to finish as much as possible. Let me call my wife, okay? Okay, so now one sample can come from boy, another sample can come from girl, right? How much money boys spend for lunch, how much money girls spend for lunch, right? One sample can come from African American, another sample can come from Caucasians. We want to check the cholesterol level. Whether African American has a high cholesterol or Caucasian has a high cholesterol, right? That is a two samples problem, two samples, because I have to compare them. So in that I want to compare the mean cholesterol of African American is equal to the mean cholesterol of the Caucasian. So requirement, two normally distributed but independent population with each sigma is known. The amount of certain trace element in blood is known to vary with a standard deviation of 14.1 ppm parts per million for male blood donors and 9.5 ppm for female donors. Random samples of 75 male and 50 female donors yield concentration means of 28 and 23 ppm respectively. Okay, so what is the likelihood? What is the likelihood that population mean of concentrations of the elements are same for the men and women? Okay, so are said same, not same, right? What is same or not same, right? So that means same means null hypothesis and alternative hypothesis is not same. It is not saying that man one is greater than the female one. Is there any indications in the question? No, right? If we reading the question, if you do not see any indication whether one group has higher concentration compared to the other, then you will set up your alternative hypothesis is not equal to. For example, I put here is not equal to, okay? I put here is not equal to. I put here is not equal to. Now, after putting these things, now test statistics value has been put there. Now, take a look here. I plug this x bar equal to 28, this y bar equal to 33. Okay. This x bar equal to 28, this y bar equal to 33. Sigma 1 square equal to 14.1 and sigma 2 square equal to 9.5. And N1 and N2 are respectively given 75 and 50. So if I plug this value in here, I got a calculated value which is equal to 2.37. Are you understanding? Understanding?
And then you have a question?
Is the 28 for the male and the 33 for the female, right? For the mean?
Random sample of 75, yeah, 75 male and 50 female donors, AL concentration means of 28. So 75 goes with this one, 33 it goes with that.
Okay,
So first one is for the male, second one is for the female. Clear, right? So and then I got the alternative hypothesis is not equal to that, calculated value is this. So this is also R code, okay? This is also R code. I also know how to write the code in R. Ultimately, after the completions of your degree, you need to use either R or Python. Python has more user, so I'm using Python. Okay? Clear? So now, reject or fail to reject. I already computed by paper and pencil for the first 7 problems, right? 8th problem, it is already solved in there. So you have seen that. So what would be the decision? The girl in the back. Calculated value greater than tabulated value. Reject. Reject. Calculated value greater than tabulated value, reject the null hypothesis. Calculated value less than table value, fail to reject the null hypothesis, okay? The note that I have written, go over that note. And you are watching my videos, right? Okay. So, statistics is the subject. Now all areas people are using. Biological science, chemistry, physics, computer science, every people. If you want to do master degree, PhD, remember statistics will be used in your life. So how can people get fascinations? The people who love music, they listen one music, another music, another music, another music. They are fascinated, overwhelmed with music, right? So they know all the album, all the artists, all the. Those people who like to watch the movie, one movie, another movie, they have their. Similarly, if you do not put attention on your study, do not give time, if you do not understand all of these things, then you will not get fascination to learn more and more and more. Understand? So in order to become an expert of a good player or good listener of music or watcher, you have to give time to them, right? Similarly, if you want to shine, you have to give time to learn new materials each and every day. Okay, so now let me do the ninth problem. Ninth problem is saying 2 sample t-test for comparing 2 means, each sigma known, each sigma unknown, samples are independent. So N1 equal to 1400, sorry, N1 equal to 14, no stairs, and N2 equal to 13 stair responses. So that means there are some group of people. So as I said, this is a two sample problems, two sample test of hypothesis problem. What we need to do in here, one group are giving response by staring on certain thing. That means by continuously looking, and other people without staring. And then the mean response was found X bar, Y bar, and their respective variance S1 square and S2 square, and also sample size was mentioned as before, N1 and N2, which is equal to 14 and 13 respectively, and level of significance equal to 5%. Degrees of freedom equal to 21. So how degrees of freedom 21 is computed? Degrees of freedom 21 is computed like this. For 2 sample N1 plus N2 minus 2, which is known as the degrees of freedom, which is equal to 14 plus 13, which is equal to minus 2. no, this is the formula for the degrees of freedom. This is the degrees of freedom formula for another problem, not for this one. Not for this one, okay? Not for this one. This is degrees of freedom for the. So if these values are plugged in there, you end up with 21 degrees of freedom. And this is the null hypothesis and alternative hypothesis. This is the way you have to compute your test statistics value. X bar equal to 6.63, Y bar equal to 5.59, S1 square over N1, S2 square over N2. If all of this has been plugged in there, your calculated value is unique. 2.43, and that is the tabulated value when alpha equal to 5% and when alpha equal to 7%. I'm going to show you this computation, okay? These two computations, this calculated value is just coming from there, and these two computations now let me show you. One is called 5%, another one is called 7%, okay? In the 5% total, if you ask me to compute, we have to use here T. We have to use here T, and then 5% degrees of freedom equal to 21. So this is the result 2.07. Are you seeing 2.07? Okay, that is the way I have computed this thing. And then another one is asked 7%. 7% means you just need to change it to 7%, 965. 1.90. 1.90. Are you seeing 1.90? So calculated value greater than table value. Result? Reject. Calculate. Remember these things. When you will go to bed today, before going to the bed, you will work like this way. Calculated value greater than table value, reject the null hypothesis. Calculated value greater than table value, reject the null hypothesis. This is one way, one round of walking you will do. Another round of walking you will do. P value less than 0.5, reject null hypothesis. P value less than 0.5, reject null hypothesis. Two walking, it will be set on your P value approach. I am going to show you in next class when I will run Python code. Clear, right? Yes. Oh, this is H0 or H1. Okay. A means alternative. You can sometimes write it HA. But this is always HO, that means null hypothesis. And it is always HO, H1 or HO and HA. A means alternative. Okay. 9 gone. Let me do the 10 one. Two sample t-test. So take a look at that. I put a condition in there. These are the condition I put. Okay, this is the condition. And that is the condition. That condition, when you read the questions, you check whether these conditions are satisfied or not. Okay, these are the condition. Now let me do the 9th one. Two sample t-test for comparing two means based on assumption that two population have equal sigma, also known as pooled two sample t-test. Pooled two sample t-test. Pool standard deviation equal to this. Now the question is, what is the question? Question is this. In a packing plant, machine packs carton with jars. It is supposed that a new machine will pack faster on the average than the machine currently used. To test that hypothesis, the times it takes each machine to pack 10 cartons are recorded. Okay? The results in second are shown below. So new machine and old machines, I am trying to compare. When I will use this, if these variance, take a look at this
at the board, please. When I will use this approach, when the variance of this is close to the variance of that, instead of using separate variances, we can use one pooled variances together. The variance are together, two data. How they have computed these things, take a look at that. Sigma 1 and sigma 2 are close to each other. In such a cases, for first data, I will find the variance. For the second data, I will find the variance. After finding these two variances with their sample sizes, if I adjust and compute that, that is called the pooled standard deviation for the two samples. After computing this is the way I have to compute the test statistics. After computing test statistics, this is the result. Now come in here. If you want me to compute these things by using Python, what I will have to do, I just need to copy these things. Okay? I just need to copy these things. And then I just need to put it in there. Control V. I put it in there and then I put like this. Go that way. It will take little time for me. Like this. Like this. Like this. I called my wife, she's gonna take care of my baby, so I'm going to stay a little longer today. Let me finish. So this is a group one, like so I put here G1 and then I write here like this and then put their square bracket and this is done. Okay, so I want to put here df1 equal to pd dot data dot frame or just the data frame, not, and then I have to put here G1. This is the way I got 1. And then I have to take out this one, copy, and then I just want to put it in there. After putting this, I just put that. PD dot data frame G2. Okay, so now these two data is in there, right? I'm not going to show you the now it is easy if I write a one line of code, everything is coming. But instead, I want to do paper and pencil approach. Okay, so what I need to do, df1 dot mean. I got this mean, and then df2, I got the mean again. df1, I got this mean, and then their variances I want to find, std, and then if you find the next one, std. Are you seeing these two are very close to each other, right? If two variances are close to each other, then applying the separate variances. So for example, here we are using separate variances, right? Are you seeing S1 square and S2 square, right? Separate variances I am using here. Here I am using separate variances. But in this case,
I'm using one variances. That one variances is computed like this. After computing these things, if results are put in that way, you will see. I have shown you how to compute S1 square and S2 square. I actually computed their STD, but if you take a square of that, it will become your variance. So if you plug everything in there, you will get result. Finally, plug in there, you will get your test statistics value. After getting test statistics value, what else you have to compute? You have to compute the tabulated value. Tabulated value is just you have to write states.t.ppf, and then what level of significance it is saying? It is saying maybe 8% level of significance. So you can put here 0.96, 0.96, and degrees of freedom equal to this one, which is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 plus 10 equal to 20, 20 minus 2 equal to 18. If you plug 18, then you will get 1.85. Let me show you how to get 1.85 so that you would not have a trouble. Here, you have to change it here 9.6. You have to put here 18, which is equal to 10 plus 10 minus 2. And then you have to, rest of the thing is fine. So you are getting 1.85. Let me see what I have. 1.85. Are you seeing 1.85? Now Python is available, we can get it quickly. But if suppose Python is not in there, then we have to use
Paper and pencil.
table that was given. The table, T table, Z table, F table, those tables are there. We will have to use those tables, okay? Let me finish one more, then I will stop, okay? This is the 10th one. Let me finish this one. Okay. Okay, let me finish this one, then rest of the materials I can cover in the after Thanksgiving. And then last class, we will do the complete discussions, what type of questions you will expect in your final exam. Again, it will be in the remotely online. You can take the exam, okay? Do you want to take the exam in class? No? Yes?
No.
Yeah, I know, the boys are saying yes. Yeah. Also that girl, this girl, and that, they are saying yes in class. You are keeping silence, so that means okay, question.
Kind of variance.
Okay, she is asking me how can I find this pool variance. Okay, there is a way to do that. I have to just search for the code. Okay, there is a way to. So if you give the results, you will definitely find it. How to like this way, find Python code to find pool variance, and definitely it is coming. Calculated pool standard deviation in Python. See, some people are doing our work. Okay, this is just the formula, right? This is just the formula, but there is someone is doing something for us here. Here, state math sample 1, sample 2. Here, computing sample standard deviation for sample 2. Computing sample 2, okay. Length. Here. What they have done. You remember in the first class, I have shown you how to write the function. You just write the function and put the argument value, then you will get it. Let me do these things, then I will stop in like 6 minutes. Here, data comes in a pair. Okay. You are one experimental unit for me, and I want to take your blood pressure before and after heavy meal. I gave her a lot of high rich protein food at 12 at noon. Before taking the food,
I took her blood pressure. After taking her blood pressure, I gave her heavy protein food. And 30 minutes or 1 hour later, I took her blood pressure. In this way, I can conduct it for all of you, right? So that means one data coming before heavy meal, another data is coming after heavy meals, but same individual, right? So this is called the paired t-test. So we want to compare how the blood pressure performance before and after heavy meal. You understand the problem? Okay, so those type of scenario, we will have to use paired t-test. Trace metals in drinking water affect the flavor, and an unusually high concentration can pose a high concentration can pose a health hazard. 10 pairs of data were taken measuring zinc concentration in bottom water and surface water. Does the data suggest that true average concentration in the bottom water exceeds that of the surface water? Are you seeing the word exceeds? So that is why it is like this. You can put your greater than, okay? So suggest the true zinc concentration in the bottom water exceeds that of the surface. So exceeds means you can put your, I put here is not equal to, but you can also put your greater than. Understand, right? So you can put your greater than, then it will be one-sided. So this is the 10 different lakes, and this is the bottom water, this is the surface water, and this is the difference between them. Okay, and this is the D, and average of this is that, this is the average of that, standard deviation of that equal to this, and this is the n equal to 10. You will get a calculated value from there, and then you are getting a tabulated value also from there. In order to find the tabulated value, what level of significance you are using? You are using actually maybe 5% level of significance you are using, as it is not mentioned. Let us see whether this is equal to 2.26. Okay, so 2.26, we want to use 2.26. So we want to use here 7.5 and degrees of freedom equal to and minus 2, which is equal to 8. We got 2.30. We got very close. Okay, we put here 9. So let me put here 9. I should put here 9. Why should I put there 9? 2.26. Are you seeing? 2.26. Okay. So we have covered 8 test of hypothesis problem and 3 confidence interval problem. Okay. What are the remaining problems? We have few more test of hypothesis, 1 correlation regression, and 1 optimizations problem. That means what values of x and y, under these restrictions maximize and minimize this equation. This is called the optimization problem. I hope I will be able to cover these things as well as R code in next class. Okay, and this is the documents, all the final exam questions coming for your final. Okay, see, I give you all the material portion by portion, part by part, so that you can focus on that, you can learn something, you can focus on that, you can learn something. Have a nice Thanksgiving break, eat a lot of turkey, stay safe, stay with your family, see you after the Thanksgiving break. Okay? Have you got the course evaluation email? No, not yet. Okay, once you get it, just start doing evaluation. Okay.
Have a break.
You too.
So the final exam is 5 topics, or would it just be questions like you've been given us?
10 questions in the Western Online, and you can take it there.